Well, there's the talk name. It's a big one. It's got a lot of words, including Apache twice. It's going to be about data ingestion from NiFi, which is short for Niagara Falls, even though nobody calls it that anymore. And but I thought I'd take a moment and say, with a raise of hands, has anyone used Apache Iceberg before? Has anyone heard of it? So the 3 people used it. Anyone heard of it? Okay. And then how about NiFi? 1, 2. Hey, I got four hands up. That's pretty good stuff. So the conversation is going to be about some ingestion strategies, how to move data into Apache Iceberg. But I would say, to be honest, I only have 40 minutes and I have to stop for Q&A. So as much as anything, this will be a quick introduction to both of those Apache projects. And I myself have been around Iceberg for a little over 3 years. And I've worked with Apache NiFi for about 8 years. Yeah, so feel pretty comfortable in those if anyone has some questions afterwards and wants to talk about there. So that's me. Good stuff. Fun guy. Old, balding, fat. But let's get going. Let's get into it. Oh, I work at Starburst. That's the Trino company. So have anyone heard of Trino? Have anyone heard of Presto? Anyone heard of Superman? Okay, I've just kind of gauged the audience based on your responses, what you really know. All right, Apache Iceberg. What is it? Well, to be honest, Apache Iceberg is, it's a data lake analytics tool. It's what they call a table format. If you've heard about Apache Hive over years ago, think of that as much the same thing. Put a bunch of files on a data lake or a file system somewhere of some sort, build a little bit of metadata around it, run queries. Analytical spaces in there. The real sweet spot, though, and this is an animated graphic, if I wasn't in my PDF, it has all these little things moving around that someone built. But the real big promise with Iceberg is we should be able to use a whole bunch of compute engines against it simultaneously. Why not? Within reason. So this is still not a transactional system, and that's why I said that, because you might go, well, all databases do CRUD operations. They do, but in the data lake space, in the analytical space, historically, that was a pretty big deal to actually change things. Other systems create it, and we bring it in. And then you could change stuff, but what's really good here is we do have true atomic, consistent acid tests. My favorite tool is the merge statement for the big data engineers out there. Caveat today is single statement transaction, so it's like an auto commit kind of concept. This is a super busy slide. So apologies for that. My wife was giving me a hard time about it. Cool, just like a database, you can do alters, good for you. But those that are in the data lake space, like Hive and stuff, you might know about that version of partitioning. Partitioning is one of those words, every tool has partitioning. It means something different. In data lakes, it really just means creating folders under a root folder where a table's located. Why? Because you're probably going to have a where clause that aligns with those. And what does that let them do? It can look at less and less and less data. And that's a good thing, actually. Everything goes faster when you look at less data. So Iceberg is unique that it lets you change that partitioning strategy, something the other ones just don't do. And just because you can do it probably doesn't mean you should all the time, but you can if you really see a need to do something like that. Again, love to come back and talk about it. The truth is, behind the scenes, all these things happen, and what is it really doing? It's just doing a new version every time you change data or change some kind of structure to the data. They call them snapshots in Iceberg. And as the nutty professor guy over there says, you can do time travel queries. Go back to hey, what did this table look like an hour ago, a week ago, whatever, or specific versions ago. I do caution people that business people get really excited about this. It's really a byproduct of the versioning and the ACID and all this stuff. I wouldn't sell this to customers and say, hey, use that for your questions that were a week ago, a month ago, a year ago. Build that into your data model yourself. Don't rely on that for this. I won't have enough time to explain it, but I'll touch on it in the next slide here. You can do all kinds of other cool stuff, branching, tagging. You can definitely roll back to a point in time too. Now, that's a busy slide. We're not going to try to explain it. What I want to say is that when the world moved out of Apache Hive into Delta Lake and Hootie and Iceberg, one of the biggest things was they said, look, let's take that. Here's the files, the data files that live somewhere, HDFS or S3, and they said the catalog or the meta store used to contain, this is the table, there's the columns, there's the partitions. The argument was that's not going to scale, so they said, let's just push all that data out onto the data lake alongside the table. And I'll show you S3 in a minute, where I have some data that lives in these two subfolders in there. They can really be anywhere, but that's usually where they find themselves. So we're not going to go into that, but there is some metadata. I'll show you some of it. And the reason I wanted to make a few points about it, because these tables then, because of all that metadata that give us all these cool benefits, we have to accept that, well, if we let it go forever, it'll be a mess. There'll be so much metadata in there. Now, it won't affect necessarily performance, but to be honest, it'll affect space, because what's going to happen is we're running these concepts they call compaction. So those that have been in that world realize there's these things we call small files, and we just want to rebuild them periodically. And if you have old versions referencing the old immutable files, guess what? You never throw any data away. So you are going to want to expire some snapshots before too long. Oh, so let's do a demo. I was warned not to do a demo, and I got 4. Why not? They're all super short. Okay, bad news is my demo is using my company's software, Starburst Galaxy. That's not the bad news. Bad news is the free version. That means every time I leave it alone for 5 minutes, it stops running. So I'm pausing while I'm pretending to dance around. All right, so this thing's going to run in a second here, but what I'm going to create, and I'm going to bump it up a little bit. Should have done that. I can also do that while maybe 125. Cool. All right, hopefully it will have started by the time I highlight this. I'm going to just create a table, nothing special. Create me a table. We're going to call it Pokemon Spawns. It's actual data. It's from the Pokemon Go data, for those that, Pokemon Go game. I would say my children play that, not me, but I understand it oh too well. I do like a Pokemon. I like a good pocket monster. All right, so I created a table, and I'm just going to do, you're like, wow, Lester, you created a table. And I did 2 insert statements, 3 records each, and then I'm going to run these 3 things, and then that'll be the end of it, whopping number 1. So I got 6 records in there, as you can imagine. No need to look at that one. But if I look at that very last command, I just want to kind of point out that, let me give it a little more room. That all that metadata lives on that file system, but most engines do give you ways to kind of see, I lost it, ways to see that metadata. In Trino, you're going to give you a SQL version. We have a thing called, we have a bunch of metadata tables. So these dollar things like that. And what do you see there? It just says, hey, look, we already have 3 snapshots. We created a table. We did an insert of 3 records, and then we did another insert of 3 records. And in fact, if we glance over on our good old friend S3, I just happen to know that that data went into need to refresh it. My Galaxy, probably, yeah, NiFi ingest. There's a long name, but it starts with Pokemon Spawns. And that font's pretty small too, but there we go. There's 2 folders, a data and a metadata. The data only has 2 files in it. Did 2 insert statements, 3 records each, really big data for sure. And that other folder, heaven forbid, already has 12 files in it, right? I wrote 6 records, there's 12 files. Okay, that's not a big deal. There are going to be probably tens, there's probably going to easily be thousands of files pretty quick. But don't think those really are read. Only a few of those are read. Hey, what's the current version and what's the associated data from that? So if you're keeping up with the world, there's a thing called Duck Lake that showed up last week, and somebody had a brilliant idea. The great folks at DuckDB, super smart people. What if we put that metadata in a database? It's not a bad idea. It was the idea that Apache Hive had in the first place, and we unwound from that because we said ultimately, maybe at Netflix scale, that doesn't scale any longer. So not saying Duck Lake is wrong. I'm surely not saying DuckDB is wrong. I am saying we all should be careful. Don't jump on a bandwagon like the first day. Let it sit for let it marinate at least a week and see if it's a good idea then. All right, full of commentary today, Lester. Good for you. All right, usually people laugh here. No. Oh my gosh. All right, so we did a quick demo. Let's talk about Apache NiFi. What's NiFi? Well, NiFi is, you hate to go to any kind of developer conference and start talking about low-code, no-code tools. People like to kind of put you on a pike, is that what they call it? Cut your head off and put you on a pike. But it is a low-code, no-code visual drag-and-drop tool. I like it a lot. Like I said, I spent a lot of time with it. It is a Swiss Army knife, I guess is the phrase we say in the US. You can do just about anything with it. And it can do a lot of things really, really, really well. It can do a whole bunch of more things, 80 to 90% pretty darn good. I challenge anyone that hates low-code, no-code tools to give it a shot. But you got to get into it. All right, so we're going to do ingestion. So are we talking about batch ingestion or streaming ingestion? Thumbs up. We're talking about them both. And I'm saying that because I'm going to abstract away from that element. It's a decision I made about a week ago when I was doing this. I was going to make it just be Kafka only. But just like Spark, when they created Spark Streaming, they were like real influential in that time because they said, look, I got a batch job. All I have to do is change where I go get my data, and the rest of the job's the same. So think of NiFi as that as well. Think of good concepts of abstraction. And I'll have a concept called a process group that says, I got you some data from somewhere. What do you want to do with it? If you would like to see some of those demos, those other stuff, come grab me. And after the session, I'll talk about it with you, show you some stuff. All right, how do you do stuff in most low-code, no-code tools? You drag, you drop, you let go, you double-click, you set some properties. You drag a connection between the next one, maybe set some properties. I'll do that in just a moment. Yeah. Unlike some of the other frameworks, there's no strong stereotypes like this is a sink or a source or something. They're just called processors. But they naturally fall into these concepts that are probably pretty normal. Selection, decision-making, enrichment, good old-fashioned just processing or transformations as well. Yeah, there's an interesting fella. I was just going to say NiFi is a little different from a lot of tools. Definitely, maybe not all the no-code tools, but software, not even all software you need to compile and build anymore, but if you're familiar, if you lived in a world like a Java world, you're still going to compile and build and all that kind of stuff. In NiFi, you throw it on the palette, on the canvas, it's already ready to go. There's nothing to do. I did call out you can build your own custom processors. Python is relatively new the last couple of years. It was only Java at first for a long, long, long time. The software itself is written in Java under the covers. Software itself is about 15 years old, so we were laughing earlier about how things are different 5 and 10 and 16 years later. NiFi is still around and still in use by about 10,000 companies, believe it or not. Nothing really to deploy. You're already in that environment. It's already deployed. Now, that said, you're likely going to want to have a test environment or production environment, and absolutely those concepts that you're familiar with of committing code and moving code around works good. That palette, that thing that I'm going to show you in just a minute, is the runtime. It's a visualization of the runtime of all things. And you want to scale it from a single node to 1,000 nodes, go for it, have fun. You don't really change anything. Now, there are going to be devils in the details. There's more to know about it. But for the most part, things are going to run the same, small, medium, or large. Okay. Monitor and reporting. These things, what you'll see here is that every one of these elements is individually startable in this magical development, building, deploying, runtime environment. And you can start them obviously from the GUI, but there's a REST API, if you want to initiate things, start them. But we think of tools like NiFi, they just run. It's a process, it's a workflow that's just constantly running. If you want it to quiesce at 3 in the morning, probably the best answer is use your scheduler and say, stop maybe the first processor that's pulling data or something like that, and then a couple hours later, start it back up. It has lots of other triggers. It can be a REST endpoint and all that, but for the most part, we think of them as nonstop, continuously running solutions, and it has intricate visualization of everything that's going on, not just the data that comes in, but it has a really rich data provenance. Long before I heard about governance and provenance and lineage, I heard about it in Apache NiFi. It is not business-friendly data provenance, it's developer-friendly provenance. What the heck happened to this piece of data? Where did it show up? When, why? And what did I say wrong? Did I pronounce it wrong? No, you're laughing at me. I need to know. Okay. It's not business-friendly. Yes. It's not business-friendly. I've built, for a few people, I've made it become business-friendly, but it itself is not. It's like I said, Iceberg has all these versions, and you can do time travel. That's business-friendly, how to use it, but it's not business-friendly when the person says, how come when I run it from 6 weeks ago and 6 months ago, it's the same answer? Because I don't have snapshots from 6 weeks or 6 months ago. I cut them off every 7 days or something. So this might be even worse than that. All right, things go wrong while they're logged. You can just kind of hover over these little, hopefully one of these red boxes won't show up and mess me up. Okay, so it's a little different. Hey, and there's more than 4 of us in here. Thank y'all for showing up today. I love it. There's more than 10. That's great. I'm happy. All right, it's a little different setup. All right, let's look at, I was going to build this, but with 40 minutes and doing a bunch of demos, you're just going to get to see it. So apologies. We will also run this in the background, so maybe that server will wake back up because we're going to need it in just a minute. All right, so over here, this is NiFi, right? There, you don't, if it's too small, just scroll in. And let's say you want to build a flow that says, go get some data from MongoDB, you know. You just type what you want, Mongo. Okay, great. Get Mongo. People use kind of normal patterns that make sense, the thing, the verb that makes sense for that tool. You know, your data get Mongo. You double click on it. You set some properties up. Where is this Mongo server and all that? If you want to parameterize those, they have, you know, all that kind of normal stuff. And then if all you want to do is get it from Mongo and drop it into S3, maybe you'll type in S3, and hopefully it'll be something like put S3, put an S3 object, drag and drop. You know, we'd have to configure them. There we go. I built a flow that says go get data from Mongo. Now that won't run because I didn't configure either one of those, but I kind of would give you the point. Pretty normal stuff, right? Grab your toolbar, use it, drop it, run it, that kind of stuff. What I went ahead and did is I built just a quick flow that I'll run. And I'll tell you this exciting workflow. Okay, so this workflow says, over here, I've got, on my hard drive, under that folder called folders, I got one called egress and one called ingest. So I'm going to pretend like I'm ingesting from somewhere, some kind of file system, data lake, and I'm going to put some data somewhere else. What am I going to get? I'm going to grab that William Shakespeare zip file that I'm going to drop in the ingest folder. I'm going to unzip it, and I'm really just going to look at make sure everything's a text file, and anything that's a text file, I'm going to look at the size of it, and call it small, medium, large, and push it. That's all I'm going to do. So nothing complicated, but just to kind of see it in action a little bit. So if I scroll out from a little higher up, I got what looks like a lot of steps to do this. This is a NiFi-ism. It just means that there are plenty of things that you do that as a programmer, you go, that's like one line of code. You're like, okay. In NiFi, you drag another processor and just say, do that thing. And don't worry, it's still going to perform. This is all passed by reference. Everything's going to be super fast. It just may look like more than you're imagining.
I'm sorry, can I ask a really
You can.
stupid basic question?
Please.
If I shoot my server, I assume that this takes care of recovery and
It sure does.
all that stuff.
It sure does, yeah. It has a whole bunch of things called, they have different repositories. That one's called the data repository.
Now, what happens, so is
Yeah.
this a stream-based thing or is it an object-based thing? So if one of my objects gets screwed up, do the other objects after it continue to be processed, or does it?
Both. It can do both because every piece of data is called what they call, it's an old term called a flow file because the system, when it was originally created, actually worked in files. It actually is really good right now in AI because we're doing we use it now for, give me all those PDFs and you break them apart and stuff. And then over the years, it got purchased by Hortonworks 10 years ago or so. And we decided to bring structured data to it. So looking at tables and all that, looking at Kafka messages and stuff. But everything is debatable. What I was going to say is an individual one of those could fail. We're going to set that aside and we're going to keep on going. Yeah.
So I noticed that you have a DAG structure. It's not just a tree structure. So things can converge. Suppose I'm doing, let's say, a join between two sides of this
Okay.
DAG. Will it wait? Can you have it?
You can do all those things. I'm going to see after the thing. There's a lot of sophistication in this. I mean, it's a piece of, you know how it is when software is 2 years old, you're still solving a problem. When it's 5 years old, it solves all the problems. When it's 7 and 8 years old, it's probably very robust in the problems it's solving. And then when it's 15 years old, it's like, is there something new that it can't do yet? And usually that is like, oh, how do we use unstructured I/O calls to
Buffer up.
every one of those every one of those lines has an independent connection that's independently on its own, managed, restored, stop, start, replayable too. Not just doesn't get lost, but you can go back and post run and ask it to replay too, which is kind of cool. It's called.
Buffer gets full, then it tells us stop.
Everything, yeah, it does. And the good news is it has to honor the problem I call computer physics. There's some problems we can't solve. Then he's going to say, you tell me what to do. So he has defaults for everything. Like, is the answer stop? Is the answer start rolling things off? Is the answer, so you got to switch for, it gets gnarly because there are a lot of switches, but for the average person, you go, okay, cut, drag, drop. Yeah. So there's independent back pressure, independent prioritization. a lot of cool options. Glad to corner you after the break. Okay, so I'm gonna run a little bit of this. Whoops, to go get files, usually regardless of where we get them, we just follow this list and fetch pattern. That way we can scale. The list is, we run that on a single node. It just gets names of files, and then our fetch can be very scalable. And really what happened is he went and, oh, we gotta drop the file in there. And my demos are not what's killing me, it's these great questions, which I appreciate. Okay, I'm gonna copy Will Shakespeare into folders, ingest, yeah. Okay, that should trigger the beginning of this to start running. Make sure, refresh, and refresh. Let's run my query one more time. Okay. Let's see if it did anything. Refresh. It didn't. Did I put it in the right place? I was expecting it to be there. Maybe I pasted it in the wrong place. Tree. Ingest. Clean up. That looks right.
You have to unzip it?
No. Why? Because I'm going to unzip it in the process. Okay, so suppose he's running. There it goes. Yay. Down in that queue right there, let me zoom in a little clipper. I'm going to right-click and just say, show me what's in that current queue. So these are queues. Don't think of that as a Kafka replacement. That queue's for the sole purpose of data's flowing from that process to this other processor, and it's only going to be there for as long as it can get done. If it takes all day to do it, that's another story. There's our zip file, William Shakespeare zip. That's all it kind of knows so far. Someone said we ought to decompress it, so let's do that. I have a little step to make sure we pick up the mine type, so we'll just do that. We'll run the unpack, we'll do that. Usually you can just start them all. I'm just kind of running it. And here's where we should see, refresh, we should see, there we go, 43 objects. Let's list the queue. There's the contents of that zip file. So we had one flow file now that burst into, 43 different flow files at this point. And the real trick was my logic was going to do a couple things. It was going to say, well, make sure it's a text file. So I didn't show you how, but it's basically a one-liner language that says, look at the file extension, look at the MIME type. And I do know that one of those doesn't match. Let's go see what's going on there. And I can, more things we can do, but I'll just say I can go look at that data, and that data makes no sense, but I know it's an image, so it's Will Shakespeare. So we say, good enough. You could purge it, you could delete it. I'm just going to leave them there for now. And then I'm going to say, guess what? Run my check file size. There's a bunch of ways to do this, but probably the best way in NiFi land would be just basically, NiFi wraps everything with a little holder object. This thing called the flow file really is the pointer to the data and then some attributes, some supplied attributes, and you can add your own. And basically I have a property. I said, hey, I just want to add an attribute. I'm going to call it size category. And I don't want you to see that code, but I'll glance at it. This is using a beautiful language, and NiFi called the expression language. And it looks a lot like JavaScript had a baby with Java, and they called it something else. I don't know. I'm looking at these guys, they'd seen NiFi before. It's still in look at the file size, nothing magical. So it added an attribute. You could build all kinds of flow if it's large, medium, but all I'm really trying to do is put this thing in a folder like S3 or something. And so why not just use that thing as a property? What am I doing? Oh yeah, where am I gonna put it? I just put that attribute, right there, big deal. Boom. Egress size. So if all went well, if I did my tree again, there we go. Broke it all apart. I only have a few smalls, a bunch of mediums, and only a few larges. And these aren't very big. They're just text files. But there you go. All right, I'm looking at my watch. It's 24 after. You messed me up with those questions.
My fault.
It is your fault, but I blame myself. All right, let's look and see where we're at. All right. Oh, we all came to talk about, those are intros of NiFi and Iceberg, but you really want to talk about how do you ingest data from somewhere via NiFi into Iceberg. That was the talk, wasn't it, Lester? So let's go talk about that. Okay. Well, I'd take a moment and say these tools, actually, I mentioned earlier that NiFi was actually created, well, we don't have any more time. Hortonworks, now Cloudera, picked up the company that runs this piece of software. It was built at a government agency in the US about 15 years ago. And they made a lot of money. Hortonworks Dataflow, now Cloudera Dataflow is Apache NiFi with some more love. And if you were listening to Snowflake, 2 weeks ago they announced a product called Snowflake OpenFlow, which is at NiFi. Why? Because the people that we bought at Hortonworks left, and I joined them last summer and helped them make the company look so good that Snowflake gave them a lot of money, and Lester got his slice and then went back to his old job at Starburst. Hey, love this world. So I'm making the point that big companies do like this too. In fact, I pitched it to my own company, since they're going to watch this video, and suggested it, instead of building our own streaming framework, why not just use NiFi? It already works, but whatever. Okay, so let's talk about some strategies. I'm going to say, we talked about batch versus streaming, setting those aside and say, who cares? Because it matters, but for us, it's okay, it's the same. I would say in data lakes, people think probably a lot about this. The tables of size and scale probably are tables that aren't changing, records aren't changing, they're just getting added to. So they're being produced, they're events, just like someone making something there, a cake or making some bread, I guess. And if that's true, based on what I saw a minute ago, where I said, get it from here, put it from there, shouldn't there be a put Iceberg processor? Well, there is a put Iceberg processor. And go back a couple years ago, it was actually a pretty nice one. But the problem now is, well, let's just talk about it. Yes and no. Did I want to say why? Okay. There is one, but we're not going to use it. I'll tell you why not in a second. But what is it really doing? It's simply saying, regardless of records coming from Kafka, they're coming from a bunch of files being pulled off a bucket somewhere, what is it really doing? It's building files that Iceberg table wants. And Iceberg needs a certain set of files. It only has a few supported file formats, Parquet, Orc, and Avro are the three Apache projects that you can use. So it's saying, let me build them right, and then let me just go over there and put them on the data lake somewhere, preferably where the table wants it, but it can put it anywhere. And then let me just push against this Iceberg API that basically says, hey, here's some more files for you. So it makes another snapshot. Sounds like a really good thing. What's the problem, Lester? The problem is, now I get to pick on the big guys. CDF still has this. And NiFi made a big jump about a year ago to NiFi 2. And so it kind of got lost in there. It only works in kind of Hadoop land. Still works on S3 and stuff. You don't have to only be on HDFS, but you kind of need to be in Hadoop. There's a bunch of libraries that are issues. Snowflake's answer, the company I went to work for last summer, Datavolo. We built one called Put Iceberg Table, because by that point we already knew we were going to get acquired by them. And so it only works really with Parquet file format, a good one, and only works with the Polaris metadata catalog, a pretty good one too, but it's kind of pointed. And the real problem is they're not open source. Those slices, they may be after after 10 million people, this video goes viral because you send it to all your family and friends. And they're like, wow, that Lester guy put us on the spot. I guess we better open source it all. Open source it. Big guys. I always tell the big guys to do work. We want to do something with open source here, so let's do this. Man, it's already 27, huh? Let's just do the same steps very verbosely. Build a file, put them on the data lake, do something to tell the system, hey, they're there, and we go off and running. So that's pretty easy breezy. The jig to myself, though, is someone ought to do the work. It's open source, so anyone can do this work. It's mostly there. I'm going to catch up with these two gentlemen on the left here and on your right, because they're going to help me take it over the finish line. Okay, so I got two demos, but being 28 after, let me tell you the whole story, switch to demo, and we'll still stop for questions. So the whole story is, I'm going to make it work. I'm still going to show it to you. But the bad news was, you as the programmer, and same thing with Put Iceberg, you need to be very clear. You need to own making sure that data is going to fit into that table. The right kind of file format, of course. You can argue, you have to know the schema, but you'd have to know that anyway, so you have to get in the right thing. But the reality is these tables, especially the really, really big ones, have a bunch of weird, likely have some additional settings that is going to be pretty hard to do as a programmer, being totally aware of all this going on. So you might choose not to do this. And the burden is, no matter what, likely coming off Kafka, someone's not messaging you things in Parquet. Likely they're not sending that to you in Orc is a big file format. So someone's got to do that conversion type. The NiFi cluster or the Spark or Trino cluster have to do that. Yeah, so what's the alternative? Well, guess what? And I should have showed you this flow already, but I'm going to show them both at the end in just a second. The other alternative is one I recommend. It's a really low-tech solution. It simply says, get that data, build, don't worry about the file format, keep it in whatever it's coming in, off Kafka, off a flat file, set it somewhere like a data lake, quickly, periodically, every 30 seconds, every 2 minutes, every whatever. So micro batch it, bulk up a bunch of things, build a quick external table pointing to it, and guess what? Use our good friend insert into to do all the conversions. So insert into my big table from this. It's not really a temp table, but this kind of hidden table from everyone. Let it do the rewrites, let it write in the proper format, take care of bucketing and partitioning and all that good stuff, and then just throw away that ephemeral table. And we can actually do this with quite a bit of concurrency too. Won't step on anyone's toes or anything like that. Yeah, that's a better solution to me. It probably sounds low-tech, but as you're seeing, all I have is the low-tech strategies. Okay, I got 10 minutes left, so I want to tell you the truth is, if that will work, which you didn't see, you're going to see it. If that would work for immutable only, append only data, what about the harder problem? I got databases that are changing, and oh my gosh, I got to sync all this stuff up. Don't overthink it. The hard part there is, how do you get those changes anyway? The whole CDC element is the hard part. NiFi can help in some of that from some sources, but it's not itself only a CDC tool. Think of NiFi as getting a set of deltas and saying, what do you want to do with this? But before I show you a solution, I want to say, because I always go back to the keep it simple model, the reality, especially in analytics, there are a few tables that are gigantic, and there's a whole bunch of tables that aren't really big. They have 10 million rows, 150 million rows or something, and they're small. They're a couple hundred, they're small. Probably don't build these elaborate solutions. Just do kill and fill. Just load those things up. If you want to refresh it every 6 hours, if you can get away with that, do that. I always say, always do the simplest solution as possible. And then on the really, really, really big tables, the good news is the solution that I didn't show you in the demo is the same solution. Build these temp tables, and instead of doing an insert into, craft you a really nice merge statement that says, hey, merge these deltas into this master table. Here's the matching logic. What do I do with inserts, updates, and delete? So I'm really just saying, use NiFi very lightweight. Let it be a little bit of an orchestrator, a little bit of initiator. And if you didn't catch the reference, because I don't know if everyone grew up with Fred Flintstone, it's quitting time, yabba dabba doo. Slide down the dinosaur. Okay, I want to finish the slides and then we'll go to demo. I mentioned there's table maintenance. There's a lot of things you can do. Vendors have, like mine, we have solutions that will automate all that kind of stuff for you. Someone has to pay for it, someone has to do it. My answer is if you got all invested in NiFi to do that much, just create a couple processors that are kicking off these activities. NiFi can be a little simple scheduled event as well. So it'll be a flow that runs all the time, but it'll basically put itself to sleep until you tell it to wake up again. All right, let's see some demos. All right, and if anyone needs an Iceberg cheat sheet, there we go. All right, demo time, Lester. Let's go to my good friend. I also have, up one level, I created a little process group here. So we're in the Q&A time. I got a little process group that's going to pretend to be either batch or data ingest or whatever. And I'm just going to run this thing. Let me start the whole thing off. Here, I can go up a level. I'm going to say, hey, run this whole group of stuff. Start yourself off. What is it doing? Well, it is looking. CD. Something similar look tree. Something similar looking before. I have these little files called Pokemon spawn. So I'm gonna copy Pokemon spawns tiny.csv into folders ingest. All right, what does that file look like? Well, it looks like that, which looks like the table I created at the very beginning, right? Lat longs, timestamp, what was it, a piglet or what was it? We've got 5 minutes left. So I'm gonna speed my demo up. So what should have happened is that thing ran and it found, not sure why it found 3 records. I would have thought it would have found only 1, which means I probably didn't flush that queue. Okay, that's okay. I didn't clean that queue up. So that queue was durable from the last time I shut my computer down. I forgot to get rid of it. I actually have the tiny in there somewhere, probably this one. And then I have some other ones from before. I have a tiny 2. So this one has 4 records. Tiny 2 has 6 or 10, 5 records, 10 records, and 363,000 records. Okay, that's fine. We'll run them all at once. So I got a little put Iceberg simulation. What did I tell you it did before? You have to convert it. That table I intimately know that it is going to convert to Avro. So let me start a few of these things. You know what? We'll just start everything and we'll talk about it since we're out of time. So he's just going to simply say, hey, as I bulk, and you can put a lot of sophistication about how often, how big, It's usually a combination of time and size of files you want to put in there. The longer you can wait, the bigger the file, the less you have to do maintenance later. But your business says, I want that data right now. So probably you're going to have to just keep jamming really quick and fast. So I converted a bunch to Avro. Hopefully that already ran through. And then I just did a put S3. We can look at that. It's going to drop it over here in this magical folder on S3, right over there. I know. NiFi, add files. So I just create a little pattern. It's a table name. So there's some files got thrown in there. That's great. And beyond that, I ran some SQL that said, it sounds like I said I'm going to use an API. Well, I'm using Trino, and the Trino way to get to this is write a command that says basically, hey, there's a function called add files. Tell it where the files are. Tell it what kind of file format it's off and running. So at this point, this thing ran. So let's go look and make sure there's at least 360-something thousand elements in there. Select count, make sure my server's running. Pretty low tech. You can beat that up and do a lot more stuff, but it's probably better it's low tech. There we go, 314,000. Maybe I'm messing numbers. It's over 300,000. All right, I'm out of time, so let me just show you that I also built on the side here this one called ephemeral tables, and that was the other approach where I said, hey, it's basically the same thing. Move it to S3, but let's just not worry about the file format. These are coming in CSVs, great. I'll run the whole thing, run. So it's going to get them, it's going to say just put them to S3, and then a guy I like a lot actually makes three processors, do this, do that, and this. I just kind of baked them together. The execute one has this notion of pre and post, so I just did a create table. I used this kind of GUID that's associated with this stuff on the fly. And then I said insert into my really big table, the contents of that, and I did a drop table. So no one's really going to see anything. If they look, they might momentarily see a table with a really nasty long name, but that's okay. By the time they query, it'll already be gone. And then I just say, what do you want to do? This model, I was going to say, what's nice about this one is when you do the add files, those files belong to that table immediately. And that's not a bad thing. It just means that they'll get cleaned up likely over time when compactions and other things occur. This model, it says, I'm not going to mess with those. When you're done with them, inserting them, you can decide what you want to do. I'm just deleting them, but probably a normal pattern might be put them somewhere else as a real bronzy raw layer or something like that. Okay, you know what? I know I ran out of time, and I want to say thank y'all for coming. And you can ask some questions, but they are going to cut us off in a few minutes. So hopefully that was somewhat helpful. That's it.
Thank you.
I didn't think I was going to clap. Sorry for the crunch at the end there.
Questions?
Oh, now he has no questions. My goodness. All right. Well, listen, I do challenge. I know a lot of people don't want to look at. Do you guys like NiFi? If you don't say anything.
We will try and then we will see.
You tried it and you resisted?
And we will see if we like it.
Oh, yeah. Okay. Well, that didn't help me. I was looking for an affirmation there. I like it. A lot of people have resistance up front. It's one of those tools in 5 minutes you're off and running. In a few days, you're like, oh, I can use this for a lot of things. And then about 5 weeks later, you realize, man, there's a lot to this under the covers, which is kind of cool when you want to do some really cool stuff with it. But I like it a lot. Iceberg, of course, is doing just fine on its own without Lester plugging it. So thank y'all for coming.
Thank you. Let's thank the speaker.